So that that concludes the portion on like structure and function. The last thing that I want to talk about today is hierarchical regression. Not to be confused with hierarchical linear modeling or multi-level modeling. Hierarchical regression is what? From the video or from what you've had experience with? Anybody have a description of what hierarchical regression is?
Adding in your IVs, like one block at a time.
One block at a time, adding in your independent variables one block at a time. Ideally, the book talks about this a little bit differently than the way that I have always done this. The book talks about adding in they have this least is last principle, right? So taking the things that really you're disinterested in or that don't matter and putting those in your model last. Ultimately, it won't matter because in the final model, it's going to include everything and control for everything kind of simultaneously. But at least it gives you this kind of, here's what happens as you add these things in. All right. And it allows you to add in the most important things first and tell you if adding new things increases the predictive power of your model or not. So let's do this. We've got a couple of different IV sets. So let's go analyze, regression, linear. Let's pull these out. We're going to leave audit problems in there. And we're going to say that we want to know, initially, we want to control for how much a person drinks. So put audit con in there. Next, we want to know how much protected behavioral strategies contributes to alcohol problems. And so next it will add in harm, stopping, limiting, and manner of drinking. And last, we want to know how these aspects of impulsivity predict alcohol-related problems. If we go with statistics, that's way more than what we need, but that's fine. Options, good to go. All right, let's hit go. Let's have a look at this. So we have 1,428 observations. Here are our basic statistics. Here are our correlations amongst all of our variables that are in our model. And this walks you through the steps where things have been entered and or removed. In this case, nothing has been removed, only entered. In a second, we will go through and do something a little bit different. This talks about each one of these models and the increase in R squared that we see. So you have an R of this, an R square of model 1, model 2, model 3. And in each one of these models, it's keeping the variables from the previous step and just looking at the incremental addition to your predictive power, moving to the next step. And so we have an R squared change right here. And we also have whether or not there is a change in F and whether or not that change in F is statistically significant. Note that this degree of freedom here is really a degree of freedom change in F. So in this first one, not looking at anything else, walk me through what's going on. Who wants to take a stab at this? This first table, I mean.
So we model 1, when we just have audit con, we see what the model's characteristics are. So R squared is 0.215 and so on and so forth. And it's then as we go to the second model, as we add PBS harm, PBS MD, and PBS SL, we can observe how much additional explanatory power those variables add to the model.
And what did they add?
0.003 in R squared, which is not significant.
Not significant. That gives us an F of 0.194. That means that they add 0.3% they can explain 0.3% of the variance, right? That's not very much. And then we move on to the next step.
Yeah, let me just look at the same things. The next step, and we see that 2% of the variance are additional percent of the variance are explained by the third set, and that is significant change.
Yeah. So here's the interesting. I heard this great discussion one time. So the last thing that we added was what? Impulsivity variables, right? And so those three impulsivity variables add an additional 2% of the variance. They explain 2% of the variance in alcohol problems. Clearly, the amount that you drink explains the most variance in the problems that you're going to have, right? Though there are a lot of people who have dedicated their careers to understanding the role of impulsivity in alcohol-related problems. I mean, I'm one of those people, right? And I heard a great talk one time by a stats guy who said one man's error variance is another man's career, and that's very much the case for me here. So if we scroll down here, we get a full ANOVA table for each one of those steps. Notice that here we have 1 degree of freedom. Here we have 4 degrees of freedom. Why do we have 4 here? Yeah, we added 3 predictors. We have 4 predictors in the model. 7 here, we've added 3 more predictors. The total predictors in the model, 1420 is obviously the number of people minus number of predictors minus 1, right? All right. Here are our regression coefficients for each step of the model. We can see that audit con in the initial step, our regression coefficient is 0.324. Our beta is 0.463. If we were to run a simple bivariate correlation between those, we would find between audit con and audit prob, it would be 0.463. That's what the correlation would be, right? This is a simple bivariate relationship. Notice our tolerance and VIF are at 1 because when there's only 1 predictor in the model, there is no overlap with any other independent variables. When we move into the next step, we added how much variance? How much variance was explained by step 2? 0.003, right? 0.3%. So basically none. We can see that within there we have 1 variable that is a significant predictor, right? PBS harm. You can see that the standardized coefficient is 0.066, but adding that variable did not increase our predictive power of the model. And that's mostly due to the fact, why is it that we have a significant predictor in this model and yet we don't say that the model is significantly improved?
Because it's so small.
It's very small, but it is a significant impact. It's because the impact is based on the set, right? And that set has three degrees of freedom, and consequently at 3 degrees of freedom, that amount is not going to be significant. If we reran this and we only put PBS harm in and we used 1 degree of freedom, what would happen? It would be a significant increase in variance explained. It would still be very, very little variance explained, but it would be statistically significant. It would be basically irrelevant, but it would be statistically significant, right? All right. If we move down to the third set, we can see that audit con, of course, is still a strong, significant predictor. PBS harm, PBS stopping limiting, and PBS MD, none of these matter, right? We do see that both urgency and conscientiousness are predictors, and They explain a significant amount of variance, which we got from up here, right? They only explain 2%, but that results in a change in F of 12.134. You can go to an F table and look at 3 degrees of freedom. What is your F cutoff, right? And an F cutoff is going to be more than 12.134 or less than 12.134. And so you have this significant p-value, which means that these add significantly to the predictive power of the model, despite the fact that it's only increasing our predictive power by 2% variance. Though, an important note, how much variance is explained by this model total? .237. So 2% is almost 10% of the variance that we can actually explain, right? And when you say it in those terms, it sounds a little bit better. It's still not great, but if we're able to explain 24% of the variance, then saying that 10% of that is due to self-control is a little bit. And remember, R squared is linear. R is not, but R squared is linear, right? So we can make that claim that this is 10% of the explained variance is due to the self-control variables, though not all of the self-control variables, right? Conscientiousness, sensation seeking is not a good predictor of alcohol problems. If we look at our collinearity statistics, anything problematic here? What's that?
It's all under 10. So.
It's all under 10. I would say that stopping limiting drinking is kind of pushing it a little bit. 3, there's some reason to maybe have a little bit of concern, but again, it's all under 10. I wouldn't be too worried about it. Your tolerance is well above 0.1. I wouldn't be too worried about that. So the question then is, how do we talk about this in the context of a manuscript, right? If we're going to do a regression model, oftentimes we will break this up into sets of variables that we want to add, and the first set is often what? What is the rationale for the first set most of the time? The book says hypothesis, but before hypotheses, it gives you a more important reason for the first set being entered into a regression model. Say that again? Confounds, yes. And so what are kind of the reason that we often control for demographics is because demographics are known confounds. When it comes to alcohol problems, the known confound for alcohol problems is biological sex. Men have more alcohol problems than women. That's just the way that it is, right? And part of that has to do with the fact that we drink, but even controlling for alcohol use, men have more problems than women, and that has something to do with the fact that men are big dumb animals. Now that's on YouTube, or it will be, so. Oh well. All right. The way that you would describe this then is you would say in step 1 we entered our demographic variables, right? This resulted in a significant model or non-significant model, and you would list your F, and it accounted for X amount of the variance in the outcome. In step 2, we entered a structural set of independent variables or a functional set of independent variables, depending on what it is, right? And we could have entered drinker status here instead of drinks, right? And then we could have gotten those differences in drinker status. That would be mean differences and problems across drinker status, controlling for all of the other variables that are in that model, right? And in ANOVA terms, that's actually called an ANCOVA, right? And you wind up having corrected means instead of raw means. But anyway, you would say in step 2 we added blah blah blah. This resulted in a significantly better model, or resulted in significantly more explanatory power of our model, or a significant increase in variance explained. You can phrase this however you want. The important piece is that you put your change in R squared, and you put your change in F and your change in degrees of freedom, right? In the third step, we added the next set of independent variables, and sometimes this third step winds up being the more important piece of these, which are interactions and or nonlinear functions. And we'll talk about nonlinear functions next week. And then you can determine whether or not there's a significant interaction, if that interaction explains significant variance, or if a nonlinear function explains significant variance in your regression model. But we have now reached a point where we are finally doing a regression analysis and describing a regression analysis. This is what your homework is going to be for this week. You're going to have a set of variables, and I will ask you to put those variables into a regression model, walk through that, and type this up as if you were writing an actual results section. If I forget, somebody email me and I will post a paper where I've done something like this so that you've got an example to kind of go by. Then we'll go from there. Real quick, I want to do one last thing. Let's go analyze regression linear. Let's pluck all of these variables out. And then let's go to block 2 and pluck all these variables out. And let's leave audit con in block 1. And let's add in our PBS variables. And let's add in our urgency or our impulsivity variables. And so now we have all of these entered in just like this, right? And let's do this. We're going to select method stepwise. And hit OK. This is an empirical approach to model building. And if you see here, when you select stepwise, it is iteratively entering and removing variables based on stepwise criteria, which are right here. And it will walk you through the models that wind up, or the variables that wind up being included. And it will pick for you the best possible model. And so it looks at audit con, and it enters that in, and it removes everything else. Then it will enter audit con and everything else, and it keeps urgency, which is the second best predictor. And then it will enter everything in, and it will select the next best predictor, in this case conscientiousness. And in this case, everything else got excluded. All of our PBS stuff. Here are the things that are getting excluded in each one of these kind of model steps. Here it only took 3 to get to that. It can take a lot more than 3 depending on the number of variables that you've got. You can also do this across sets. So we could have gone consumption in block 1. We could have went to block 2 and specified PBS. And then it will specifically pick consumption, and then it will move to block 2, and it will enter in block 2. And then we'll move to block 3, and it will enter in block 3. If you do it that way, you're going to get the exact same results that you will if you just enter everything in block 1, though. So. This is not a theory-driven approach to building models, right? This is very much an exploratory approach to building models, and it allows SPSS to iteratively add in and remove predictors to figure out what is going to have the most explanatory power in your model. And at the same time, be parsimonious. And so this is what we get here. Ultimately, none of the PBS variables matter, and sensation seeking doesn't matter, which is actually what we had seen in the previous model anyway, right? So don't use stepwise. If you, it's often used in like genetics research when they have a ton of different alleles and they don't have any real rational theory for why certain alleles should be predicting whatever they're trying to predict. And so they enter a bunch of stuff in and see what comes out hot. For the most part, I have, I'll be honest, never even reviewed a paper where people have used this approach. And so I was taught it as a graduate student and never touched it again after that. Maybe in business it's different, right? I don't know if business is as theory driven as some of the other. Okay, then there we go. Maybe it's not. I tend to think of business as like econ, like take everything in the market and throw it in a model and see what comes out. But I could be wrong about this, right? So, okay, that is everything for today that we're going to go through. Are there any questions, comments, concerns for me? No? All right, cool. I will get your guys' homework up later on today. And it's going to be, like I said, a regression model where there will be a couple of different small things. I'm going to have you guys do some grouping stuff, and then but the main thing is a results section that looks at adding variables across steps. Sound good?
For the results section, usually we talk about like outliers or what have you. Do you also want us to?
Let's not worry about that right now.
Okay.
So don't worry about any of that right now. Let's just worry about the basic results. So in the past, I have posted I think that I have it on there, right? Maybe I don't. A sample kind of results section that you guys should plug your information into. Did I give you guys one of those? Is it on there? All right, I will put that on there, just like a template, right, to plug everything into. So, all right, cool. That is it, guys. Have a good weekend. Yep, I will see you tomorrow at bright and early.